Hello friends and welcome to YouTube channel on Engineering Mathematics by Dr. Navneet. Friends, in this video lecture we are going to discuss the topic which is called as exact differential equation. So in this video lecture we are solving four important examples. After watching these four important examples, you will be able to solve the example based on this exact differential equation form. Now friends, before solving the example, let's discuss the theory part. So here the theory part is that a differential equation, so this is the definition of exact differential equation. A differential equation which is obtained from its primitive means a solution by differentiation only and without any operation of elimination or reduction. Such an equation is called as an exact differential equation. So this is the simple definition of exact equation. Now friends, here the standard form of this exact differential equation is mxy dx plus nxy dy equal to 0. That means here coefficient of dx is in terms of x and y, coefficient of dy is in terms of xy, or we may say that, so this m, that means this term is the function of two variable xy or constant. So this coefficient of this dy, that means the term n is the function of two variable xy or maybe constant. Then such an equation is called as exact differential equation. This is the standard form related to the exact differential equation. Now friends, there is one important theorem which is related to the condition for this exactness. So this theorem says that the necessary and sufficient condition that the exact differential equation m dx plus n dy is equal to 0 be exact is that partial derivative of m with respect to y equal to partial derivative of n with respect to x. That means both way it is possible. So this equation is exact if this condition hold, and vice versa if this condition hold, that means given equation is exact. So this is the condition which is called as condition for exactness. This is one of the important theorem in exact differential equation. Now friends, coming to the points. So here we are discussing the method of solving exact differential equation. So these are the four important steps for solving any equation in terms of exact differential form. So very first step for solving the example is that, so consider the equation m dx plus n dy is equal to 0. That means whatever equation is there, first try to convert that equation in terms of this standard form. That is the first condition. Now friends, second step is that, so find the value of m and n. So here m means the coefficient of dx, n means coefficient of dy. So that means find the value of m and n. After finding these two values, find out the partial derivative of m with respect to y. Again, find out the partial derivative of n with respect to x. This is the step number 2 for solving the example based on exact differential equation. Then step number 3 says that if the partial derivative of m with respect to y equal to partial derivative of n with respect to x, if this condition hold, then according to this theorem, we say that given equation is exact. So this is the step number 3 for solving the example based on exact differential equation. Friends, there are some example where this condition does not hold. So we are solving such type of example in our next video lecture. So as a time being, just try to understand the method of solving exact differential equation. Now fourth step is that solution of this equation is obtained by the formula integration of m dx. So here m stand for the coefficient of dx. In the first integration, y is constant, plus integration of terms of n which are free from x. That means only choose those terms from n which are free from x, that means avoid the x term, into dy is equal to c. So these are the four important steps for solving the exact differential equation. Once again, standard form of the exact equation, find the value of m n, partial derivative of m with respect to y, partial derivative of n with respect to x, then check whether these two partial derivatives are equal. If these two derivatives are equal, then given equation is exact equation or exact differential equation. Then this is the formula for obtaining the solution. So based on this method of solving the ordinary differential equation, let's try to solve the first example. So friends, here first example is given. So example is solve dy by dx equal to x minus 2y plus 5 divided by 2x plus y minus 1. So our aim is to solve this equation by exact equation method. So very first step for solving example is that first convert given equation in terms of m dx plus n dy. So if we rewrite this equation, then we get this as, take this denominator to this side, so we get this as 2x plus y minus 1 into dy is equal to, this is x minus 2y plus 5 dx. So we just take the denominator from this left side to this side and this dx to right side. Now to get this standard form, so this is dx, now take this term to this side, so we get this as x minus 2y plus 5 dx. Then after taking this term to right side, we get this as minus, then this is 2x, so this sign is 2x, so this is 2x plus y minus 1 dy equal to 0. Now friends, after rewriting this equation, we get equation in our standard form. So this is m dx plus n dy. So in this way we get the step number 1. Now let's perform the step number 2. So here the value of m, so value of m is x minus 2y plus 5 and that of value of n is minus. Actually here minus sign is there, but in our standard form sign is plus. That's why we are taking the sign for n as minus. So this is the minus sign, then 2x plus y minus 1. So for our simplicity, we can write this as minus 2x minus y, then this minus minus become plus 1. So this is the value of n. So here we get the value of m and n. According to the step number 2, find out the partial derivative of m with respect to y. Now if we try to find the partial derivative of m with respect to y, then in this case the value of x is constant. So now this is the constant, derivative is 0, then partial derivative of minus 2y is minus 2, then again 5 is constant. That means partial derivative of m with respect to y is minus 2. Similarly, find out the partial derivative of n with respect to x. When we take the partial derivative with respect to x, then y is constant. So here derivative is minus 2, then this y is constant and 1 is also constant. So in this way we get step number 2. In step number 2 we find the value of mn and partial derivative of m with respect to y and n with respect to x. So we come up to the step number 2. Now step number 3 is that check whether these two partial derivatives are equal. So here the partial derivative of m with respect to y equal to minus 2 and which is equal to partial derivative of n with respect to x which is minus 2. So as these two partial derivatives are equal, then according to this condition we say that given equation is exact. So this implies that given equation is exact. So given equation is exact equation. So in this way we perform the step number 3. Now friends, let's perform the step number 4. So step number 4 says that solution of the given equation is, so solution is, according to this formula we can write this as m dx. In the first integration y is constant plus integration, take only those terms in n, so that means terms in n which are free from x, dy is equal to c. So this is the standard formula for solving the example. Now put the value here, so we get this as integration. So value of m, so value of m is given which is x minus 2y plus 5 into dx plus integration. So this is the value of n. From this value of n, take only those terms which are free from x. So this is the first term where x is available, so just drop this term. Next term is minus y plus 1, which is free from x. That means in these two terms x is not available, so we can take the term minus y plus 1 into we can write this as dy is equal to c. In this way we use the formula for a solution of exact differential equation. Now just find out the integration of this term, but here the term y is constant. So we can write integration of x as x square by 2 minus 2y is constant. This middle term is constant because in this integration y is constant. Then integration of 1 is x, or we may write this as minus 2xy or minus 2yx, plus this is 5 is constant into x, integration of 1 is x. Then for next we can write this as minus, so this is y, integration is y square by 2, plus again this is y is equal to c. So in this way we can easily find out the integration of this term. So for our simplicity we may take the term 2 common. So if we take the term 2 common, we get this equation as x square minus this is 2 to the 4, this is xy after rearranging the term, then plus 5 to the 10x minus y square plus this is 2y is equal to. Now here we take the term denominator 2 common, so we can write this as 2, and after taking this 2 to the right side, so we get this value as 2c. So in this way we get the solution to the first problem, which is very simple. So this is the way to solve the exact differential equation. So friends, this is the first example. Now let's take the second example. Now friends, let's take the second example. So here second example is solve y square e raised to x y square plus 4x cube dx. That means this is the value of m plus 2xy e raised to x y square minus 3y square dy is equal to 0. So our aim is to solve this example with the help of exact differential equation method. So now friends, according to the method of solving this example, first step is to write the given equation in the standard form. But already this equation is in our standard form. So here this is the value of m dx plus this is n dy. That means this is the value of m and this is the value of n, so which is equal to 0. That means step 1 already available in the given example. Now let's find out the value of m and n. So here the value of m is, so value of m is given as this is y square e raised to x y square plus 4x cube. This is the value of m. Now similarly the value of n is given as 2xy, so this is 2xy, then e raised to x y square minus 3y square. So these are the values of m and n. Now according to this step number 2, find out the partial derivative of m with respect to y and n with respect to x. So now take the partial derivative of m with respect to y. When we find the partial derivative of m with respect to y, then x is constant. So here y is available in the first as well as second term. So we use the product rule for this partial derivative. So according to the product rule, so first term as it is y square, derivative of e raised to x, derivative of e raised to x is e raised to x. According to this formula, we can write this as x y square as it is. But this is other than x. This is other than x. So derivative of this x y square with respect to y. So we can write this as 2 times xy, because x is constant and derivative of y square is 2y. So this is the first term plus second term. So we can write the term e raised to x y square as it is. So this second term as it is. Then derivative of first term is 2y, because derivative of y square is 2y. So in this way we get the value of partial derivative of m with respect to y. Similarly, find out the partial derivative of n with respect to x. when we find the partial derivative with respect to x, then y is always constant. So now here x is again present in the first as well as second term. So we use the product rule. So first term as it is, 2xy as it is. Then derivative of this term is e raised to x y square. But this is other than x. So derivative of x y square is y square. Because we are taking partial derivative with respect to x, y is constant. So then plus second term. So second term is here e raised to x y square into derivative of first term. So derivative of 2xy with respect to x is 2y. So then again minus 3y square is constant because we are taking partial derivative with respect to x. So in this way we get the partial derivative of this m with respect to y and n with respect to x. Now check that these two partial derivatives are equal. So this first term and this first term is same, and this second term and this second term is also same. So therefore we say that partial derivative of m with respect to y is equal to partial derivative of n with respect to x. As these two partial derivatives are equal, that means these two terms are equal. So this indicates that given equation is exact equation. So given equation is exact according to the step number 3. Now friends, to get the solution of this equation, apply the step number 4. What the step number 4 says that m dx in the first integration y is constant plus second integration terms in term of n which are free from x, then dy is equal to c. So this is the standard formula for solving the exact differential equation. Now put the value. So this is integration. So value of m is, this is y square e raised to x y square plus 4x cube into dx. So this is the value of m. In the first integration y is constant plus second integration. Now friends, while taking the value in this second integration, take only those terms from n which are free from x. So this is the value of n. So in this first term x is available. That means we have to drop this term. So second term is minus 3y square where x is absent. We can write this as minus 3y square dy is equal to c. So in this way we put the value in the standard formula for the solution of exact equation. Now next step is to find out the integration of this term. Now while finding the integration of this first term, consider y as constant. So we can write this as y square as it is. Then integration of e raised to x is e raised to x. According to that formula, we can write this as integration of e raised to x into y square as it is. But this is other than x. So derivative of xy square with respect to x is y square. Because y square is constant, derivative of x with respect to x is 1. Then plus we can write this as 4. Then integration of x cube is x raised to 4 upon 4 minus 3 we can take outside the integration. Then integration of y square is here y cube by 3 equal to c. So here this 4 will get cancelled, this 3 will get cancelled, and we can write the solution of this term. Again this y square will get cancelled. We can write the solution of this term as e x y square plus x raised to 4 minus y cube equal to c. So in this way friends, we get the solution of this equation with the help of this exact differential equation method. So this is the second example. Now friends, let's take the third example. Based on this exact differential equation. Now here example number 3 is solve dy by dx is equal to y plus 1 upon y plus 2 e raised to y minus 1. So to solve this example, so let's apply these 4 important steps for solving the example. A very first step is to convert the given equation in terms of standard form. So this equation is not in the standard form of exact differential equation. First try to convert this in standard form. Take this dx to this side, so and this term to this side, we get this as y plus 2 then e raised to y minus x, so into dy is equal to, this is y plus 1 into dx. So but to get this standard form, so this is m dx, this is n dy, but take this left side term to the right side, so we get this as y plus 1 into dx. So after taking this term to the right side, so sign is minus, then this is y plus 2 then e raised to y minus x dy equal to 0. So this is the step number 1 where we convert the given equation in terms of standard form of exact equation. Now next step is to find the value of m and n. So here m means coefficient of dx. So value of m is y plus 1 and that of value of n is minus. So we take this minus sign here because for this standard form of this exact equation middle sign is plus, but here we are getting minus sign, that's why we take the sign for n as minus. So this is minus, then in bracket we get this as y plus 2 e raised to y minus x. Then for our simplicity we can write this as minus y plus 2 e raised to y, then this minus become plus x. So this is the value of n. We just multiply this minus sign to the inner side. Now after finding the value of m and n, our next concept is to find out the partial derivative of m with respect to y and n with respect to x. So here if we take the partial derivative of m with respect to y, then we get this partial derivative as 1. So the derivative of y with respect to y is 1. This one is constant. Now similarly, if we take the partial derivative of n with respect to x, when we take the partial derivative with respect to x, then y is constant. So here y term is there, then total term is constant and its partial derivative with respect to x is 0. So now derivative of x with respect to x is 1. That means these two derivatives are having answer as 1. So we can write therefore partial derivative of m with respect to y is equal to partial derivative of n with respect to x. As these two terms are equal, then we say that given equation is exact. So this implies that given equation is exact. As given equation is exact, then use this formula for obtaining the solution. I will directly put the value to that result. We can write this as integration of m dx. So value of m is y plus 1. So we can write this as y plus 1 dx. In the first integration, y term is constant plus, so this is integration of. So according to this formula, take only those terms from n which is free from x. So this is the value of n. Here x is available, so we will drop this term. So then the term which is free from x is minus y plus 2 then e raised to y dy is equal to c. So in this way we use this formula to obtain the solution of this equation. Now just simplify this. So here in the first integration, so this term y plus 1 is constant, because y is constant, then integration of 1 is x. Then here we can take this minus sign common. Then here two terms are there. So to find out the integration of these two terms, we use general rule for integration by parts. So the general rule for integration by parts says that, so first function integration of second minus derivative of first integration of second plus second derivative third integration and so on. So this is called as general rule for integration by parts. If we apply this rule here, then this is the value of u and this is the value of v, right? This is the value of u and this is the value of v. So here we have to apply LIATE rule for finding the integration of this term. So this is exponential and exponential is the last term. So that means to find out the integration of product of two terms, first we have to check the LIATE rule. Then apply this general rule for integration by parts. So here value of u is y plus 2 and that of v is e raised to y. Now just find out this integration. So we get this as u as it is. So this u as it is. That means we write this as y plus 2 as it is. Then v1. v1 means integration of v is v1. So integration of e raised to y is e raised to y as it is according to the standard formula, minus, so here this is u and derivative of u is here. So derivative of y plus 2 is 1. So derivative of y plus 2 with respect to y is 1. Then again v2. v2 means integration of v1 is v2. That means integration of e raised to y, which is again e raised to y. Then next term u double dash. That means u is here first derivative, then this is second derivative. So y plus 2 first derivative is 1, second derivative is 0. That means all remaining terms are 0. So this is the end of this example. Then equal to c. Now just simplify this. We get this as this is xy after simplification. This is plus x minus this, we can write this as y e raised to y minus 2 e raised to y, minus minus become, this is minus minus become plus e raised to y equal to c. So now just combine the y term. So together we can write this as xy plus x minus y e raised to y. Then we can write this as minus e raised to y equal to c. Or moreover, we can write this as x into y plus 1. So here from this term we take the term x common. Then here if we take e raised to y common, then this become y plus 1 equal to c. Now friends, the fourth example of this video lecture is solve tan y plus x dx plus x sec square y minus 3y dy is equal to 0. So already friends, this example is in our standard form for solving the exact differential equation. So here directly value of m is given, which is tan y plus x, and that of n is given as x sec square y minus 3y. Now find out the partial derivative of m with respect to y. When we take the derivative with respect to y, x is constant. Derivative of tan y is, this is sec square y. Then similarly partial derivative of n with respect to x equal to. So here friends, when we take the derivative with respect to x, then this sec square y is constant. Derivative of x with respect to x is 1. So this indicates that partial derivative of m with respect to y equal to partial derivative of n with respect to x, because these two terms are same. So according to this step number 3, given equation is exact. So this implies that given equation is exact equation. So this implies that given equation is exact equation. Now apply this formula for obtaining the solution. So here solution is, so we can write this as solution is, so we write this solution as integration of m dx. So value of m is here tan y plus x dx. In this first integration, y is constant plus integration. Take only those terms from in n which are free from x. So here first term is x sec square y. That means x is available. So drop this first term. Second term is minus 3y, where x is absent. So we can write this as minus 3y dy is equal to c according to this formula. Now just find out the integration. So here in the first term, this tan y is constant because we are integrating with respect to x, and here y is constant. So then integration of this term is x plus integration of x is x squared by 2 minus 3 times integration of y is y squared by 2 equal to c. Moreover, we can write this as 2x tan y plus x squared minus 3y squared is equal to 2c. After taking denominator 2 common and taking to the right side. So this is the fourth example based on this video lecture. Now let's take the last and fifth example of this video lecture. Now friends, the last example of this video lecture. So example is solve sin x cos y plus e raised to 2x dx plus cos x sin y plus tan y dy equal to 0. Now our aim is to solve this example with the help of this exact differential equation. Now friends, this example is straightforward in our standard form. Now here the value of m is, so value of m is, so we can write this as sin x cos y plus e raised to 2x, and that of value of n is, this is cos x sin y plus tan y. Now according to this step number 2, find out partial derivative of m with respect to y. So when we take the partial derivative with respect to y, then x is constant. So here this sin x is constant. Then derivative of cos y with respect to y is minus time, this is sin y. Then derivative of e raised to 2x is 0 because we are taking partial derivative with respect to y. Similarly, take the partial derivative of n with respect to x. When we take the partial derivative with respect to x, then y is constant. That means this sin y is constant. Then derivative of cos x with respect to x is minus, this is sin x. Then again tan y is constant according to this partial derivative with respect to x. Now if we observe this term and this term, so this is minus sin x, this is sin x, minus sin, this is sin y. Therefore, partial derivative of m with respect to y is exactly equal to partial derivative of n with respect to x. So according to our step number 3, if this condition holds, then given equation is exact. So this implies that given equation is exact. As this equation is exact, we can write the solution of this equation with the help of this standard formula m dx. Value of m is sin x cos y plus e raised to 2x into dx. In the first integration, the term y is constant, plus integration. Take only those terms in n which are free from x. So here this is the value of n. So here cos x is present. That means in the first term x term is available. We will avoid this term. Then next term is tan y. So we can write this as tan y dy equal to c. Just find out the integration of this term. So here when we integrate with respect to x, this cos y is constant. Then integration of sin x is minus, this is cos x, right? So then plus, so we can write this as e raised to 2x upon 2. Integration of e raised to 2x is e raised to 2x, but this is other than x, so derivative of 2x is 2. Plus, so then integration of tan y, so we know that this is the standard formula, which is log of sec y equal to c. So friends, here we solve a total 5 examples based on this exact differential equation. I hope you understood all these 5 examples. So if you understood these 5 examples, then you can easily solve any example based on this exact differential equation method. Now friends, time is to take some example for your practice purpose. Now friends, here time is to test your knowledge. That means solve this example for your practice purpose. So first example is solve 2x plus 3y plus 5 dx plus 3x plus 2y minus 5 dy is equal to 0. Directly we get the standard form of exact equation. So solve this according to these 4 steps for solving the exact differential equation. So you will get answer as x square plus y square plus 5x minus 5y plus 3xy is equal to c. Then second example is solve dy by dx equal to y upon 2y log y plus y minus x, and answer is xy minus x square log y equal to c. Now third example is solve y e raised to xy minus tan x dx plus x e raised to xy minus sec y dy is equal to 0. So So this is the value of m, this is the value of n, directly standard formula. So now answer is e raised to xy minus log of sec x minus log of sec y plus tan y equal to c. Then fourth example is solve tan x tan y this is fourth example, sec x tan y tan x minus e raised to x dx plus sec x sec square y dy is equal to 0. Answer is sec x tan y minus e raised to x equal to c. And for fifth example is solve y plus x sin x dx plus x minus 2 e raised to y dy is equal to 0. And answer is xy minus x cos x plus sin x minus 2 e raised to y equal to c. So these are the 5 examples which are given for your practice purpose. Solve all these 5 examples. So friends, here we discuss the exact differential equation. I hope you people like this lecture. So thanks to one and all for watching this video. Thank you.